All right, so I would like to talk about a quick concept, which transformations are going to affect the equations of our asymptotes and in which ways. First, we're going to take a look right here. We have the function f at x equals 1 over x. That's our typical base reciprocal function. It has no transformations applied to it. It looks, when I graph it, let's give ourselves a little bit more space here, it looks like this, right? I can see that my function has acts very wonky right around my x-axis and right around my y-axis. If I follow this along, it looks like my function, as I go to a large negative number, if you will, looks like my function approaches y equals 0, but if I follow along, I'll find that it doesn't quite reach y equals 0. Same thing in the positive x direction. My function gets closer and closer to y equals 0, and as I follow along, it will approach but never reach it. And that's what we call the asymptote that our function is acting around at that stage. Now, in this particular case, we can see relatively easily the equations of our asymptotes, right? We can see where those would come from. That would be a vertical line. We should have a vertical asymptote where x equals 0, as you can see in pink here, where our function is approaching but not reaching that vertical asymptote. We can see that our function goes to extreme high values right around x equals 0 from the right side, and extreme low values right around x equals 0 from the left-hand side. And I can also take a look, and let's try and give ourselves a little more space here. I can also take a look at the horizontal asymptote right here. I can see that my cyan function there is approaching this horizontal asymptote but never reaching as it goes to extreme values. So I can see the equations of my asymptotes here. I have a horizontal asymptote where y equals 0 and a vertical asymptote where where x equals 0. Now, if I take a look then at a new function, g of x equals 1 over x plus 1, well, then what I'm doing, I'm going to turn my asymptotes off for a little bit. Then what I'm doing, I know, because we've studied them by this point, we've studied them enough to recognize that what's happening here is I have one transformation that's a translation 1 unit up. And I can see that's true if I plot my orange function at the same time. If I plot g of x here, that it looks like all of the points have been shifted, have been translated up 1 unit. Now we'll turn off the base function here, and we'll take a look at our asymptotes. I can see right off the bat that these asymptotes are no longer both accurate. It looks like my vertical asymptote is accurate. If I zoom out, it looks like my orange function there is approaching my vertical asymptote, and that's great. But my horizontal asymptote, that's off. My function is no longer approaching that value. My function is now approaching a different value. And if I zoom in a little bit more, I can see that my function, rather than approaching y equals 0, my function is approaching y equals 1. So it looks like our function here, the asymptote, got also translated up 1 unit. So let's try that out. We'll try and change the equation of our vertical asymptote. Rather than y equals 0, we'll try y equals 1. And we can see that that lines up much nicer with our equation. But let's try a little bit more. We'll take a look and we'll say, okay, what if we apply a vertical stretch? A vertical stretch to our g of x as well. So not just having this the vertical translation, now we're applying a vertical stretch. So we'll multiply this entire fraction by 3. That's a vertical stretch. And we just want to take a look and see how the equations of our asymptotes are changed. Well, right off the bat, I can see it looks like my asymptotes are still lined up. I need to zoom out a little bit more, but still my function is approaching y equals 1 to extreme x values in the positive direction and extreme x values in the negative direction. So it appears as though a vertical stretch or compression, I can try that as well with, rather than 3, I can compress it by 1 over 3. Either way, my asymptotes will be the same. So the equations of my asymptotes are unchanged from vertical stretches and compressions. That will be true as well for vertical, That will be true as well for vertical reflections. If I take away this compression here and I multiply it by -1, there I can see it's reflected. Sorry, let's get so I'm able to show it a little bit nicer. Perfect. I can see it's being reflected vertically, but at the same point, the equations of the asymptotes are unchanged. I can try the same thing with a horizontal reflection. The equations of the asymptotes are unchanged. Now, how about a horizontal compression? Unchanged. A horizontal stretch? Unchanged. I might need to zoom out, but I still see it, that my asymptotes are still in the same location. How about a horizontal translation? Yes, I'm trying them all. I'm going about it in a pretty aggressive way, and that's all right. A horizontal translation, and that I can see changes where my vertical asymptote should be. I'll need to change my horizontal asymptote the same amount that I just translated my function. So my function's been translated over here 3 units to the right. If that's the case, let's try translating our horizontal asymptote 3 units to the right. There we are, and we see it lines up nicely. Now you will find with an exponential function, these same transformations will affect the equations of our asymptotes in the same ways. I encourage you, try that out, throw that into Desmos and play around with it with an exponential function and see how it works.